All right, hello. Hey, okay, here's what we're gonna do. We're gonna add batching really quick. It's really late in the day. Don't usually stream this late in the day. We'll see how it goes. Well, I want to add batching. What we did in some previous streams is we built our own deep learning machine framework from scratch without any help other than with the help of a library called NumPy. NumPy helps us with for loops and things like that, making it really clean and simple to read the code. So you can check out here, for example, some nice little math functions that come along with NumPy that allows us to do lines like this. This line right here would normally take multiple for loops and some interesting nesting, and we can do it all in one line, really clean and simple and easily. That's why I like NumPy, because it makes that sort of syntax a lot cleaner. You would have to write this as a for loop to iterate through this, and then you have to write another for loop because it's a multi-dimensional array, and then you have to, hey, July, how's it going? It is super late. I know. We're very late today. We had a lot of meetings, but I still wanted to go live and add batching because, July, thank you for recommending we added the MNIST training set. And guess what? It worked. It actually worked. It was amazing. We did have a little challenge with some divide by zero. We do need to fix that. Well, we don't have to fix it because it works just fine with it. It works just fine, but it has these warnings on it, which are these warnings right here. You can see on the screen. And I like things to be clean and simple and not have any warnings in it, right? Don't you like having your code without warnings? I do. That's how I like it. You fire up, Steven? Yes. I'm really excited. I know it's like really late. I've been up since 4 a.m. and it's already 5. So wait, it's 12 hours. All right, been awake for 12 hours. I'm so excited. But also I've been in meetings all day long. So we're like, no, we finally get to talk about AI. So I'm really excited about it. I'm really excited. All right, so here we go. So check it out. It's actually really cool. Let's do this. So I'll show you July. Check it out. It's really cool. So here is our learning rate in epochs. We did here. We'll do 100 samples because this will be a batch. We'll do a batch size of 100 because basically we're doing a batch size 100%, but we need to add batching during our train section right here. See X and Y. We need to update our train method to do batches. But for now, we don't have that. So we'll just say 100 samples. We'll save that and then we'll run it. And it'll learn. It actually learns. Oh wait, I got a pie. Oh, it doesn't matter. Okay, see, look, check it out. Really cool. Check it out. Okay, so I have this comparator to see. I do want to turn these into green check marks so it's a little bit easier to notice, but it gets everything perfect. So this is just the training data set. This is the training samples. It is learning. It's actually able to learn, which is very exciting. That means we wrote our own machine learning framework from scratch, and it can use the MNIST data set. Isn't that cool? I think that's really cool. So one of the things I wanted to do real quick was, here we go. Let's turn these trues into like a green check mark. Let's turn the trues into a green check mark. I believe it's here at the top. Here we go. So I think it's like this. Where is this? Is this it right here? Yeah, this is right here. So this is true or false. We can say what was it? So if can we how do we do range. Here we go. So we've got this here. Let's go up there. All right. So I want to do something like this. Okay, so we could do this. So we do green check mark like this. I like this. Green check mark. If else, let me do else like this. Then we do like a no entry, right? Like error, failure. All right, see, now let's rerun it. And instead of all those trues, we're going to get a whole bunch of green. Wait, hold on. Wait, else. Did I type else right? Wait, hold on. Oh, wait, can I not do that? Is that something I can't do? Wait, I put it in the wrong spot. Syntax, you guys. We gotta make sure it's correct in the syntax. All right, here we go. July or. So batch is when you mean the gradient cross across all the elements of the batch. Yeah, so it'll be batches. See, look at all the green check marks. It's so pretty. It's all green. We can probably do something to make it a little bit even prettier. Okay, so we could probably do let's see, display equals this, like this, right? And then we could say like this. We say display dot. Wait. No. What do you want to do? We want to merge it, right? We want to join. Yeah, we want to join like this. There we go. Join. There we go. Like that. Green. I know it's green everywhere. It's so cool. I love it. All right. So we got display. let's rerun it again. So now our greens will look very pretty. And if you just see a bunch of green check marks, that means it's good. That means it's good. Oh, whoops. Oh no, I can't do a join on that. It won't let me do a join. List object has no attribute join. That's because I did it wrong. Because in other languages, you have to do it like this in Python. Isn't this weird? It's like the opposite. It's like the opposite of what you'd think. I'm pretty sure that'll work. Here we go. Okay. It should just be a nice, there you go, perfect. A beautiful display of green check marks. That's good enough. I'm happy with it. It's perfectly fine. Okay, here we go. So now that we have a pretty display of green, what we can do next is, let's do batching. Let's add some batches, right? So here is our data set. And then we want to add a batching. So if we do like batch size, we could have like a batch size or something. Let's go in our model. When we do our train, let's do batches. Let's get our batches. Okay. So we've got number epochs, and then how are we going to do this? So we've got our features and labels. So we need to do batching. Let me, it already knows what I wanted. We don't have to use it. Hey, Foo, how's it going? Is this what writing code is? It is what's writing code. You're totally right. This is writing code, you guys. We're writing code right now. We're updating our from scratch machine neural network that we wrote in previous streams, which is only a few lines of code. Well, right here, it's like the most important part is right here you see on the screen. This is the critical aspects. It's all the important parts for typically the most modern approach when it comes to the state of the art for machine learning. Do you stochastically sample the batch? Yes, we should. We totally should. So we should do it. We should add it random. So we should do it randomized. I've written my own, I've done this several times in the past. I've written several models like this in the past. All we have to do is we have to grab, we just need to get a random. We can get random numbers and we just need a batch size. So we've got a batch size. Let's do batch 32. And then we want to see the input. So we do inputs equals features. Yes. This would be, and let's see, how do we do this? We need to do, so inside, I think we have to do it inside here. Like this, or inputs, and then we grab the features, and then we get the batch size, but times, something like this. But it's not stochastic. When you say stochastic, that means random. So we have to add the random aspect to it. So let me turn off Copilot disable, because we're in hard mode here. We don't want to. We're not getting too much help from the AI is the idea. We're not getting too much help from the AI. Okay. Also, I do have, we've got like maybe 20 minutes. We got 20 minutes. We can do it. We can do it in 20 minutes. Okay. So we've got our batch size. We don't need to say plus. Well, we do need to, in this case we do. So this will give us the features, but will it give it the right? So wait, we need to do batch, or we need to go batch like this. Don't we have to do it like this? Times I time batch. Wait, hold on. Wait. Foo, is this how people make interfaces for like apps and websites, or what is this make sense? If that makes sense. It does, Foo. You make a really good question. Okay. So this is behind the scenes. This is like the AI part, the part that doesn't have a UI. In fact, this is what the UI looks like on our screen. If you can see, this is what the UI looks like, because in this case, we're just printing our data to the terminal window, right? To the terminal output. So you can see here, this is our results. And green check marks is a good thing. We want to see the green check marks. If we wanted to make a website or web app, we'd have to write some code that represents UI, things that represent the UI. And you can do this in a lot of different ways. There's a lot of different frameworks that let you do this. HTML and CSS is one of the most common ways, which allows you to create buttons and UIs and images and make it really pretty. But this is just Python. This is just Python, you guys. Green, I know, green, so cool. I like it so much. Yeah, I think this is a fancy term for random, isn't it? It is, yeah, it is. This is the thing, like in computer science, there's so many fancy terms, and especially in artificial intelligence and machine learning, there's all these fancy, like the gradient. It is basically just an array. It means an array. It's a very specific kind of array, but it's array nonetheless. There's only one kind of array, really, but it has a purpose, like an intent. So calling it the gradient, for example. So we don't need this anymore because we were debugging, but we need to get rid of that later. Yeah. So we need to do some randomness here. So I think we can do. How do we do random? I forgot. Let's do Python. Is it import random, something like that, and then also NumPy has a random too, doesn't it? Import NumPy as np.rand. Is it rand? No, random. Let's see here. What is it? Random. Okay, here we go. .rand int. Is it rand int? Wait, 1? Here we go. Okay, we can do that. But we rand int 1. What is this? 7? Okay, 1 to 7. Okay, perfect. Perfect. Here we go. So we can just use NumPy. We don't have to import math or anything like that. There we go. So we can just do this instead. Where is our batch at? Here we go. Get our batch going. So we've got a random. So see here, random like that. Okay, so we'll figure out. We'll figure out. So we do want. So what we want to do is we want to fill the array with a range that is the size of the batch. So we go range batch like this. So that is a range, and then we can say for I in we'll do, and then we do np.random like this. So we'll wait, almost. We'll figure this out. Okay. So this is, so we've got a range for I in range like this. We're going to do some list comp here. We'll do some list comprehension. All right, here we go. Okay, so for I, that will give us the size that we're looking for in terms of a batch. But what we want is to grab the feature based on I. So we just do this, I like that. And then this will create us the features. This will give us the features for so we can do this. We can do inputs like this. I think that's it. Right? Is there anything else we got to do here? Is this it? I think so. I think that's it. Okay, so we'll just say continue, and then we'll like skip the rest of this. XP. Here we go. Continue, and we print inputs. I want to make sure that looks right. So we'll do like batch 5. We'll do a batch size of 5, and then we'll see if that looks good. And then we'll set the epochs to 2, something like that. And then we'll run this here, run it, and then we'll see what it comes back with. We'll see if it gives us what we're looking for. Don't worry about those red marks. We're fine with red marks. We don't need to worry about those. We're totally fine. Don't worry about the red marks. Said, hey, Ugo Bright, how's it going, Ugo Bright? Welcome on in. We're going to do some machine learning. We're adding batching into our model. Oh, is this it? This looks like it. So this is a batch size. We said 1, 2. Wait, no, is this it? Let me double check. No, that's the results. Here we go. We don't want that. So let me turn off all. We've got way too much printing happening here. So print. Here, let's go ahead and turn those off because we don't need those anymore. We don't need those. We don't need this anymore either. Let's turn that off. Sequence K, how's it going? They're inside the mainframe. Yes, we are. We're inside the mainframe, everyone. We're inside. We have time. And we have time left. Okay, let's get rid of, we don't need the weights. Let's see what else. We don't want the results. What we'll do is we'll just say return. We'll return immediately after training. Return, here we go. Now we can get our results that we want to see. All right, here we go. Oh, that doesn't, is this right? Yes, I think this is it. So this is our training samples. This looks about right. Okay. So this is based on the batch size. This looks correct. Okay. I think we did it. Okay, perfect. Perfect, you guys. We did it. Okay, great job. Thank you so much. This looks so cool. Check it out. Okay, here we're going to do the train. So here's the training. Wait, hold on. Timeout. Wait. We're almost there. We almost have the algorithm perfect. But I'm actually surprised because this is the inputs. We're like, did we finish it already? It's like out. Wait, we'll say inputs and then targets. I like to use the word targets. There we go. And then this will be not features but labels. Here we go. Labels, you guys. Sequence K. Oh, this style is so hard to intuit for me, and I know basic Python. Yeah, it is. It's list comprehension. It basically just says create an array. Good job, Stephen. Break that code. That's what we're gonna do. We're gonna break it. We're gonna make it happen. So we've got our batch size here. Maybe what we could do is do batch here and like have a capital letter, and we'll just put like 5 up here or something like that. Batch, and then this is not good practice. Don't get me wrong. This is not good practice. We don't want these global variables doing our things for us. We don't like the global variables doing things for us. But what I could do for now is actually just like this, like that. Okay. So now we've got our batch size, and we've got our inputs and our targets, our features and labels. We're looking good. Let me do some alignment there so it's easier to read. So it's easy to read. What are all these zeros and ones? Is this just our computer without any information to read, or how do you explain? I'm lost. Okay, so the zeros and ones that you see here on the screen are MNIST data set. Because July, who's also in chat, was recommending what do we do with our AI model? So we created a machine learning model from scratch. How do we test it further? How do we make it look good? And so we have these things called MNIST, which is a handwritten letters, a whole bunch of handwritten numbers actually. 0 through 9, so 10 different letters or numbers here, symbols, and it's the training data set. And so what we do is we take those numbers and we can put them into our AI model, and then it's going to be able to predict handwriting. It's going to be able to predict handwriting. So whenever you write the number 2, whether you squiggly or 2 like this right here, which is a really weird number 2, or you write a number 4 like this, or like this, different ways to write number 4, we'll be able to extract that. And then boom, you did it. We did it. That's the answer. .bat for batch files is fun for old school command prompt scripting, Sequence K. Batch files from Windows, the old bat files. I remember those. I definitely remember those. Now we're doing Python these days. Whoops. Oh, you don't want to see that. You saw nothing. You saw nothing. You didn't see. Nothing showed up there on the screen. Okay, here we go. Inputs and targets. We're good to go. So we got inputs and then targets. Targets. Here we go. I think that's it. Is this it? Did we just implement batching, you guys? Did we just implement batching already? Is that it? Is that all it took? Now I know we need to do some math here, because our batch size, we need to increase our range based on the epochs. Okay, so if we want to train 100% of the data, but our batch size is 32, say we need to do some math here to continue to loop on the iteration. Continue to loop on the iteration. So wait, we're getting the numbers. We're getting the for I, and do we don't. Okay, so here we go. So let's do a different number here. There we go. Something like that. Here we go. So that way we don't get things confused. We want to make sure our code's clean and happy. Okay. So this will loop. This basically runs 100 batches, not 100 epochs, right? So if we have like 100, this will give us 500 data samples. But it's not. The term epochs is not correct in this case. We need it to match on the number of training data sets. So we need to say the length of, we need to say not epochs. Oh, how do we do this? Epochs times, so we want it to run, how many? Okay, let's do the math. Let's figure this out. How do we do this? So if we've got say 100 features. Let's say we had 100 features, which is 100 trainings. Can you show an example of return values instead of globals? Return. So instead of globals, what we'd want to do is add we'd put the information. So like on our .train function, we would want to pass in batch size, batch equals, and then we'll just say 5, and then epochs equals. Let's do 10, right? We'd have to do something like that. We'd do something like that. That's what it would look like instead of globals, and that's a much better approach. We'd also need to update our learning rate, and so these things I'd have to. What do we do here? Okay, we would actually, let's go ahead and do that, because this is not good practice. You don't want globals. That's like one of the things you don't want to do. That's like just one of the common patterns. Okay. Let's go ahead and do that. Let's make that a thing. Let's do it real quick. Let's do it. Okay, here we go. So put this here, but we don't want it to be capitalized, so we'll lowercase it. And then instead of that, what we'll do is batch. We'll just put it here, batch size, learning rate, and then learn_rate like that. I think we could do something like that. Oh, I said, hey, how's it going? Perfecto. Thank you for the likes. Epochs equals train rows divided by length, rows length. Thank you. That's what we're looking for, July. Thank you. That's what That's what I want. I want that. Okay. Let's see if we can do this. And then learn. I'll just say learn equals. So we do this like this. 0.001 batch. Okay. We're good. Let's do that. Okay. So we got rid of the globals. Now we just need to say batch like this. So we need to. See here. What was it? What was our train function look like? It's like this. Okay. Let's go like this. There we go. So we need to say batch equals. We'll just copy and paste this directly. So these are like really good defaults like that. So we'll just do this. We'll make it so like they're really good defaults. Perfect. Okay. Then we go over here. We say batch, and then we have epochs like this. And then let's take July's epochs equals train. Thank you for the likes, you guys. Rows, the number of rows divided by the batch. Okay. All right. So rows. So that would be features, which would be length, right? So we do len equals features. So that's the number of features in the training data set. And then you said divide by batch. So that'll be the batch size, right? And so, but we want like 10 epochs, right? So we want 10 epochs. If that will that get us 10 epochs? Batch size. So if batch size is 5, but let's say the features is 100, calculator. So we'll say 100 divided by 5 would be 20. So that'll run through 20 iterations. That'll be 20 iterations. Also, this isn't like perfect precision because this is randomized. So we're not gonna. It won't be a true epoch. This won't be like pulling in. I think this is good enough. We actually might miss some. We'll miss some data. It won't train on everything. In this case, it won't train on everything because we're not doing 100%. So we're missing some parts. Hey, the FP2 guy. Hello. How's it going? Welcome on in. We're implementing a good enough batching for our AI algorithm. It's good enough batching for our AI algorithm. It's what we're doing here. And so also, what is our learning rate? We need our learning rate. Where do we put that at? Okay. So I think this, we'll just say self dot. Okay. Self dot learn equals a learn like that. And then we have this capitalized here and we'll say self dot learn. Here we go. Something like that. There we go. I think that did it. We solved it. We got rid of the globals, which is nicer and cleaner now. We got some nicer and cleaner. Looking good. We're looking good. And then let's see if we can get our batching working. Let's see if we can get our batching working. So it's not perfect batching and it's not fully perfect, but I think we're good enough. All right. So this gets us close, right? So it's not, this gets us, this tells us to 20 times. Oh, and then we need to multiply by 20, right? So we'll just say epochs, right? I think it's an epochs times features divided by batch. So this says do it 20 times. Okay, we did it. That's it right there. Are we done, you guys? Are we already done? Is that it? Is that all it took? Right there, you see on the screen? That easy to implement batching for our AI machine learning model? I don't know. Let's find out. Is it going to work? Wait, let's go to print. Hold on. I don't want to print a whole bunch of stuff. Let's see if we can. Let's see if we can keep it easy. Print. Looks good. Looks good. Print. What else? We don't want to print. Predictions, results, fine. That looks fine. Okay, let's just see. Let's see what happens. Is it going to work? I don't know. Oh, no, it didn't. Oh, we got to spell correctly. Where did we put that? Well, 86? Okay. 86. Epochs. So spell epochs correctly, you guys. Yes, spell epochs correctly, not some weird random epoch spelling. Okay, here we go. Is it going to work now? Nope, something else is wrong. Oh, no. Okay. It is because of object cannot be interpreted as an integer. Ah, I see. Okay. I see. So was it features? Wait, which part of this line can't be interpreted as an integer? It can't be this. I mean, clearly that has to work, right? Batch, epochs, cannot be interpreted as an integer. How do we fix this? How do we fix that? We want this. Let's see. How do we make that work? Can we just do this? Well, actually, or do we want to say float? Float like this, but then it's not going to be an exact number. Maybe, I don't know. Len will be an int, but maybe float here, something like that. So I don't know. We're gonna find out. Hey, hello, Fiddle, how's it going? Welcome on in. We're implementing batching for our machine learning model that we created from scratch. Is it gonna work? Is it gonna work this time? Nope, still not happy. I made it afloat. All right, well, maybe we'll make this one afloat. All right, let's see if that works. Maybe. All right, we're just going to see if we can make it work, and then we'll make it better. We'll make it better. Oh, it's still not happy. You guys, what's wrong? Object cannot be interpreted as an integer. Type float. Oh, we've got some sort of weird error. Cast everything to an int. Okay, let's do it. We'll do an int. Here we go. Int. There we go. Int. F. There we go. Oop, nope. There, nope. Int. All right, perfect. Everything's an int now. It's all cast to an int, you guys. You need to be. Oh wait, that also didn't work. What? Do you regularly do coding tutorials? Yes, we do. Sage 84. We do. We're just a little bit later than usual today. Hey, Lolkek 99. How's it going? Welcome on in. You need to do to be in an int so you can iterate. I think that's It does. It does need to be an int. You're totally right. But everything's an int now. Why isn't it working? Put the int around the feature batch. Oh, I got it. Okay, you know what you're talking about, don't you? You know what you're talking about. There we go. Okay, let's try that. Let's try it. Here, let's. There we go. Is it gonna work this time? Is it work? Oh no! Oh wait. Okay, it worked. It worked. Thank you so much. The division is making it afloat. Thank you. You guys figured it out. Thank you. Okay, the name target is not defined. That's okay because we can figure it. It's called targets. We'll say targets, whatever. Target, here we go. Perfect. All right. Just a little bit misspelling. You guys figured it out. Thank you for helping me so much. Okay. Now we've got another problem. Oh, come on. Self-learn isn't there. Oh, because self.learn. It is. We made it. We made it .learn. Wait, did I spell it wrong? Is it in correct spelling? Because we're typing so fast, you guys. Learn. Here we go. Self.learn. Looks good. Self.learn. See, it looks good to me. It looks, oh, wait, train. Oh, that's because the layer. We're doing it on the layer. Oh. Okay, we've got to do something else. We got to do something else here. I figured out what the answer is. For I in range, epochs times len features divided by batch. Maybe do a floor division for precision issues. Lost lab? Yeah, we might need to do that. We might need to do a floor. We might have to do a floor, or we can cast the int here. I think is actually cool. I think this will work. I think we're doing okay. Jack Yellow, welcome on in. We're doing some machine learning today. We're adding some batching to our machine learning model that we wrote from scratch, and I think we basically did it. But what we need to do is where is it? So forward, self.forward, and then when we do the backward, self.backward, which is over here, we need to update the layer to include the learning rate, which is not clean. I'm not happy about it, but you know what? It's going to be the best we can do, which will happen right here. So self.learn, Learn, here we go. And we say like this, we go like layer, Layer learn. I think that'll be fine. Maybe. Hello, Atlasia Agency. Wait, Atlasia Agency. Atlasia Agency, how's it going? Welcome on in. All right, let's see if this works, you guys. Is this going to work? If it works, we did it. Oh, stuff's another problem. List attribute has no attribute. Oh, does it? Does it not? Why not? What do you mean? Self.input. Did I type it wrong? Layer.learn. We broke some stuff, you guys. We broke it. We're like, we're just going to do some simple batching. It will be no problem. Easy peasy. But it turns out it wasn't as easy as peasy. It wasn't so easy. Scale the gradient with self.learn. Yes, that's what we're doing. You got it. You know what's happening. You know exactly what's happening. You know it exactly. All right, so why self.op, so layer.optimize. Maybe what we could do is just pass it in here, just like this. Learn like this to make it simple, like that. There we go. Also, we might. Was it? Maybe. Oh wait. No. That should be fine. I think we're good still. All right. Let's double check. All right. So we got to go up to our optimize function up here. Or optimize batch. Wait. Do float division. And then. Oh wait. / Oh, that's a whole. Okay. Thank you. Okay. Let's do it. All right. // There we go, Lost Lab. I see what's going on. We needed an extra forward slash in there. I forgot you could do that in Python. I forgot you could do that. Python like this, right? So we go 1.1 and then forward slash like 2.0, right? That does, but then what happens if you do 2 forward slashes? Oh, wait. Are we sure we like that? Are we sure we like that? 10. Oh, okay. So what if we do 200? 200 divided by 10, 20. And that, wait, so that does that changes it, right? So if we do 11 versus forward slash that. So, okay. So that rounds it for us. There we go. Okay. So we did it. Double forward slash. That is super weird. I'm not used to that. I am not used to that. 1 second. Let me check my text messages. Let's see here, because I do got to get going at a certain point. Okay. Let's see here. Let's see if we can do it. Let's see if we can make this work. I know we're really close. Okay, so we got that. Optimize missing one parameter, which is learn. We can figure that out, right? Learn there. Let's get rid of that. And then we've got our self.learn. Let's see, self dot. I think that'll be fine because we've defined it here. And so we've got it here. And that should work. That should work. Arcsy, interesting. I think so. I think we're almost there. Let's get rid of this. We don't need that anymore. Okay. Let's see if it works. All right. So we solved that. I know we solved that. Okay. Backward takes 2 positionals. We got something. 3 were given. Oh, did we do it on the wrong thing? Oh, we did it here. Oh, we have to oh, because backward includes. Okay. So we have to do one more update. So we're polluting. I need to clean this up later. I need to clean this up later. This has to learn. All right. So this is not what I like. I do not like this. I don't like it, but we're trying to make it work and we'll clean it up later. List object has no attribute T. Input. Oh, got it. Okay. I know what we did. I know what we need to do here. Here you go. So we just need to do np.array like that. We figured things out, you guys. We're figuring things out, probably. I don't know. Let's find out. Is it going to work? I don't know. It worked. Hey, check it out. Oh, this seems okay. So this is so cool. Check this out. It got the data. It got the did it? Yes, it did pretty okay. But we need it to do better. Python rage baiting is interesting. No. I know. So I really need to clean this up here. I really need to clean up variables because we need to do that. We need to do that because this is a to-do item. To-do like this. We need it. Must happen. Let's go. Thank you for the likes, you guys. We did it. I'm so excited. This is so cool. All right, we need to clean up variables. This is really important because I like tidiness. Pass gradient does self-learning in the backward pass. That's you got it. You got it. That made it work. But since back did we do it here? Do we need it? No, we don't need to do that because we got self.learn here. This is the model, but then the layer has it here, and this is the backward pass.learn. So we will make an improvement. We will make the improvement. I'll be able to figure it out later. But for now, at least we got it working. Okay, so we want to do 1,000 epochs. Let's do 1,000 epochs, and we'll do 5 batches. Batch size of 5. Yeah, that's fine. Okay, here we go. Let's see if we can get it to all green. Is it going to all green? Is it going to go all green? It almost did because here's why. The batching isn't perfect. It's random. It's random batching. So we won't get all greens. But I'm very happy with this result. Let's see if we can. So what we can do is we could increase the batch size and then also increase this. Here we go. Let's make it happen, you guys. Let's make it. Boom. Okay. It's going to run. It's going to train. It's still learning. Oh, we got it. It's mostly all green now. Check it out. It's so cool. So this means, you know what this means? We do have to get going. But what it means is now we don't need to do this anymore. We don't need to do that anymore. But it's going to be very interesting. How many data sets? We do have to do this down here when we do our results. When we're doing prediction, we don't want to do this. We want to do something like this. We'll do X tests like that. Something like that. But actually, there are some other tests up here, aren't there? There's some X tests and Y tests here. Let's just do this. We'll do this. Okay. X test, Y test. We'll do it like this. What are the green? Why is it green? What is the green? Is it a good prediction? Yes, you got it. What is green anyway? In this case, it is what you're seeing here on the screen. Okay, so it's the data that it learned on. It was just X is what it was. So it was still the features that it trained on. So we know that at least it learned. So hey Cheetah, how's it going, Cheetah? What am I looking at? You're looking at some machine learning that we wrote from scratch ourselves. In previous streams, we were very successful in doing it. We just made it a little bit messy with some learning rate things, but we'll clean it up later. But it's really still pretty simple. It's still pretty simple right there. Okay. Same Cheetah, King George. We are, and is it worth procrastinating on over a med school exam? Oh, Cheetah. Actually, I mean, here, okay, my opinion, I mean, you're in med school. Okay, so in healthcare, in medicine, school is very important because we have a whole bunch of rules to follow and, things that you want to go, hey, Arksy, hell no. Yeah, exactly. Arksy's got, please, if you're going into medicine, focus on the medicine because a lot of people and human lives depend on you so much to get everything correct and not make any mistakes. So hell no is the correct answer. Hell no is the correct answer. Okay. So we're going to do one last thing here. We're going to see here. Let's get our X test and Y test like this. Here we go. Like this, like that. Okay. So, and we're going to get our prediction and we're going to do it like X underscore test like this. We'll do it like that. Yes, I think that's good. Well, let me check here. What is going on up here? What is this? Wait. We have to do something here. Let's see here. What do we have to do? We have to do the same thing. Okay, let's do the same. Let's just do it like this. I've got an idea. Let's do underscore test like this. Like this. There we go. And then we'll do it like this. And we have to do the same for y. Y underscore test like that. Equals this, like this, y test. There we go. We're almost there. Lamau, Air, good luck with your stuff. I'm going to give you a follow. Thank you so much, Cheetah. Appreciate it. We'll make it work. It's going to happen. We're going to make it work, you guys. We're going to make it work. Okay. This has to be, instead of Y train, it will be Y test. There we go. I believe, or is it? Yes. And then X test is like that. And then Y train's like that. Okay. So S test, Y test. Perfect. So this is our testing data. Testing. And this is our training data. Training. Perfect. We did it. We got it. Okay. Looks good. Let's get rid of this. We don't need that anymore. Let's get rid of some of that. We don't need any of this. Looking good there. Okay. So then we're gonna update this and we're gonna capture these things like that. So we'll only do a sample of 100 on our test. Okay. How many epochs should we do? How many epochs? That's a lot of epochs. I don't know. That's gonna take a long time to train. Let's see. It's probably. Oops. Wait. Oh, you didn't see anything. You saw nothing. You didn't see that. Okay. Cannot reshape. Because. Wait. Cannot reshape array size of really big into shape that. Really? Why not? Uh-oh. Okay. Here's what we can do. I've got an idea. We won't use the test data. We won't use the test data for now. Instead, what we'll do is we'll just do this, colon 100, something like that. We'll come back and do that later. So we'll do this and then, like this. Use 5, 10 for whole data. Use 5 to 10. We'll have to sample down. We'll have to sample down just to make sure it works. And then I have to get going. And then I have to go because I've got a thing to get to. Unless I don't, because I'm not seeing any text messages back. Wait. Nope. Okay, we're good. Okay. Here we go. All right. So, y colon, like that, colon 100. So that'll just get us 100, the first 100. There we go. Just the first 100. There we go. And then X, we'll do the same for X, here. We'll do it here in the X and Y train. We'll do it here. So we'll do it like, well, let's see what happens. Let's see how it happens. All right. Is it going to work? I think it'll run this time. It'll run. Okay, perfect. And now it's going to take very long time. I don't know how long it's going to take. We will have to size down. but it is learning. It's learning. It's figured it out. Look at that. It's still learning. That's crazy. It's learning, you guys. Lost Lab. What would you be interesting but difficult is to train the logic on a low-level language using Pio3 for Rust. Are you talking about Rust or to like make a library? And import it so your Python program's like 20 times faster? Yeah, we could totally do that. So we can import some libraries so it makes it way faster. Yeah, that totally would work. You're absolutely right. King George, is YouTube Reels the only place you're live? Yeah, it is for now. It is for now. What is Pio3? So Pio3 is, at least I've used it with Rust before. It lets you use a faster language like Rust. You can compile and target a binary. And then you can create basically a library or a linked library that you can then import into Python, and it gives you a much faster performance. Rust bindings, Lost Lab, you got it. Rust, it is Rust Labs. Lost Labs is Rust bindings. You got it. Cockroach Pichu, how's it going? Hey, what's going on here? We just did some machine learning, our own deep learning neural network that we wrote from scratch live on stream, and we just added batching. We just added batching, which batch support right here. We did it. It's not perfect batching. It's still random. So it's going to miss some inputs and some training data, but it's definitely working. So this is going to probably take forever to run. So we have to reduce the amount of data that we're training on. Let's do like 1,000. Let's do 1,000. I think that'll be good. Let's do like 1,000. All right. It's something like this. Let's do where are we gonna go here? All right. Let's do this. We'll just do it on 1,000 samples like this. 1,000 like that, and like this. Here we go. There we go. Copy. And then nope. You saw nothing. You didn't see anything. Okay. There we go. So we'll do that. Then it will train. It should complete. Within like a minute. Maybe in a minute. It depends. If you're calling a Rust function from Python at the very iteration, it is going to cost much more time. It will. So what you need to do is maybe do like matrix multiplications. So you pass in the matmul into Rust, and the matrix multiplications can be a lot faster in Rust, for example. A lot faster in Rust. It seems quite nice. What's the purpose for your particular? Size is different from 28. Input operand 1 is a mismatch. Is that because where's that at? Where's that at? What line? There? Really? Okay. So that's probably on the forward pass. So let's just do this. Let's make it clean. Let's make it run a little bit faster so I can see where the error is more easily. Where's the error at? So I do believe it. Oh, well, no. Oh, here's why. This is it right here. We have to do this for now. That's what it is. Okay. There, we fixed it. We'll have to do something else later. We'll get to the X and Y train and X and Y test distinction later. So seems quite nice. What's the purpose? The purpose is learning. We're learning. So if you're going to be building a machine learning, your own machine learning model, you're probably going to use PyTorch directly. So you do PyTorch like this. You'll be using PyTorch. And it has hardware acceleration. So you don't have to worry about, writing your own algorithm from scratch. But what we're doing here with our own stuff is we're learning. Hey, look, there it goes. We did it. We added batching, you guys. Isn't that cool? We added batching. It's so good. Lost Led, I'm sure there's some alternatives to Pi9 if you are not a Rust fan. And I just read a book on Rust interoperability with Pio3. Yep, Pio3. There you go. Also, there's another one. We did this recently. We did live on stream, Pio3. I'm not sure if we used Pio3. I think we used a different Rust binding. I suck at coding, but new to YouTube channel has 10K views in 6 days. Okay, I would notice some things about your shorts that would help you gain lots of views. Recently deleted number 5. Let me know. Absolutely, let me know. So I'm actually really happy with what we've done here. It's not perfect batching, but I think we should. We actually get really good results. We actually get very good results. Let's increase the number of epochs here. Oh, number of epochs was already really high. Let's do 10,000. Let's see if we can get all of them green. My last short got 504 views in 15 minutes. That's actually pretty good. I think that's pretty good. That sounds pretty good. Oh, that didn't work. Let's do it. Let's do another one. Let's do another one because it's stochastic, right? It's random, so it's not going to get everything. What we need to do is update our batching. That's good. It's really close. It got 1, right? See, it missed 1. You saw like it needs. I need 100% green check marks. I need 100%. I want 100%. Oh, that didn't get 100%. Okay. But thank you for the likes, you guys. Okay, I think we did it. I think we achieved our goal. It was we added batching. Oh, it's so close. It's just 1 off. All right, here. Let's do 20,000. We must be able to get it in 20,000, you guys. I'm a guy who writes the algorithm for YouTube. You did recently deleted? You did? So that means that I could use a coding friend. There you go. That would you always need a coding friend. I would say you always. What is this? Come on. Let's see if we can get all of them green. Let's get all of them green. Or get them at least really close. Really close. What can you use this for? Sorry, being a script kiddie. Oh, Tommy Gunner. So basically anything, basically everything. Basically absolutely anything. So if you do, if you want to make your own sort of intelligent computer system and you're building, you build AI, right? That's what you need. You need artificial intelligence. So this is the way to do it. Oh, it's almost all green, you guys. It's almost all green. It's so close. It's so. Oh, you know what? It's probably we could increase the number of parameters we got here. We could increase the number of parameters. Let's do that. Let's see if we can make that happen. But then we need to change the. We need see if that. Wait, did I save that? Did I save that? Oh, I totally did. Look how much fast. That's really slow now. You can see it's really slow now. Oh boy, super slow. Here we go. Resize. Hold on. Resize panel. Resize pane. There we go. Dash D 10. Here we go. Okay. Oh, wait, did it work? No. Is it go? Okay. Looking good. Okay. So I do have to get going. Py3 is fantastic. You can pass Python types to Rust and vice versa. You don't have to take care of the conversions with vex string. It's a list string. That is very useful. That is super useful. Okay, I am satisfied that we are not going to make it any different than where it's at right now. What we need to do, you subscribed and like. Thank you. Thank you, recently deleted. I'll have to go and talk to you later. All right, we are going to wrap up here. Let me just do a couple of things here like that and then bring this down. We'll do 2,000 and then see where we get with this. I think we're doing, we did plenty of batches. We're good to go. I think this is plenty good. This is plenty good. I know we didn't get all the greens. Oh, it's so close to almost all greens, isn't it? I just want it to be all green. I like it to be all green. It can be if we do 100% of the data and we do even batching, but we're not doing even batching. We're doing stochastic batching, and it's possible to miss some data, and some data is not going to get trained on evenly. It's not even training. And so that's when, okay, so what we need to do tomorrow is upgrade our batching. So that's that's the plan for tomorrow. We'll upgrade our batching tomorrow. This is what we'll do tomorrow. Okay, so here, let's add a to-do for tomorrow. To-do, improve batching. There we go. And we do this by, see, it's got to be even distribution. Is that how you spell distribution? Okay, what floating point size do you use to the default or high precision? Loss lab. I do believe, what is it? What in Python is it? It's probably float 64. I think we're using float 64. So it's very high precision. It's like super high precision. We don't need to make it that big. But right now, this is our own machine learning from scratch. So we're only using CPU. It's not hardware accelerated. We're not using a GPU or a TPU. So that means that it's just running on my CPU, which is plenty fine, especially for the MNIST dataset. It's plenty fine for the MNIST dataset. But what is your education background, King George? I have some college, but I dropped out to go into business. I dropped out and went into business, you guys. And it worked out really nicely for me. I would say I'm very happy with the outcome from that. If you're in college though, keep going to college unless you've got something better. But otherwise, keep going to college. Like I've been asked that question before. Should I drop out? My answer is yes, only if you've got something that you are working on that is better than college. So resize dash up, and we'll do like 10. There we go. Wait, that didn't work. Resize pane. We go. Actually, a pane dash up, and then we do 10. Here we go. Oh, that's way too much. Can grow as much as they need. Python uses arbitrary sized numbers. Oh, does it really? 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 I didn't know that. Okay, I just got a text message response. Okay. All right, I got to get going, you guys. All right. Thank you for hanging out. We did it. We got our batch. We have a plan for tomorrow. We're going to improve the batching here. So we got to do this. Here we go. This is what we got to do tomorrow, right? We got to improve our batching. Like that. We got to improve our batching, you guys. That's what we got to do. And we need even distribution. We got to do this. Even distribution here. That's the plan for tomorrow. They only drop out. We're going to talk here on one of the nodes, right, Stephen? Wait, July, wait, let me double check. What are you saying? The only dropout we're going to talk here is on one of the nodes. If we want to do dropout, yeah, we can add that. What time, King George? I don't know. I'm not sure. So my meetings are back to back, and whenever I have like a chance to like sneak out, then I go live. But usually my meetings are all back to back. So I won't be able to confirm a specific time, King George, but it will be sometime tomorrow. It's definitely going to happen. It was good to hang out with you guys. Thank you so much. We're headed out now. We did it. We added batching in only 50 minutes. We did it within 50 minutes. 50 minutes. Isn't that crazy? We did it in 50 minutes, you guys. Ah, it's so cool. We did it in 50 minutes. All right. Thank you for hanging out. We're headed out now. We're clicking the stop stream button. We'll be back tomorrow, and we will improve our batching so that way it has a nice even distribution so we don't miss anything in our range. Because the reason why is because we got, look at right here. It's like right there. Oh, you can't see it perfectly. But right behind the Python, there's one red block right behind the Python. Here, I'll show you. Oh wait, no, here, check this out. See, look, right behind the Python. Where is it? Text. Here we go. So there's one red dot right here. I don't know if you can see it very well, but we want to solve that. We want to get everything perfect, you guys. It's got to be perfect. I want perfection. So we'll do perfection tomorrow. Thank you for hanging out, everyone. That's crazy. I know. I think we can do it. I think we can totally do it. I think it's possible. Perfect. Near perfect. Good enough. Perfect. We'll make it happen. We can definitely make it happen. Type of thing that would not let me sleep. I know, right? It's off by one. It's not perfect yet, but we'll do it. We'll make it tomorrow. So that's the plan for tomorrow. Thank you, everyone, for hanging out. We'll be back tomorrow.